In this video, we're going to be learning about momentum. Now, momentum is the tendency for an object to keep moving in the same direction. So suppose we have two vehicles. We've got a lightweight car and a very heavy truck. If they're both moving at the same speed, then we can say that the truck is more difficult to stop because of its large mass, and that means that it has a large momentum. Now, there are two factors that affect the momentum of an object, and that's the mass and velocity. Now, before we move on and look at some calculations, we need to understand this concept of conservation of momentum. Now, what it simply states is that the momentum before an event is equal to the momentum after an event, and these events could be collisions or explosions. So we're going to need this equation, P equals m times v, where P is the momentum, m is the mass, and v is velocity. The mass is measured in kilograms. Sometimes you may get a question where the mass is in grams, in which case you have to convert it back. The velocity is measured in meters per second, and the momentum is measured in kilogram meters per second. The other point I wanted to go through was, does the momentum depend on direction? Because velocity is speed with a direction, and that the momentum is a product of both the mass and the velocity, then we can say that the momentum can also have a different direction. So if you look at these people here, A and B, both have the same mass, the same speed, but in different directions, which means that they're going to have momentum in the opposite direction. So that's why I've got a minus sign here and a positive sign for person B. So our first event we're going to be looking at is collisions. So I've got a question here that says a car with a mass of 1,200 kilograms traveling at 5 meters per second collides with and becomes attached to a truck of mass 20,000 kilograms traveling at 2 meters per second. Calculate the velocity of the joined truck and car after the collision. So this car over here is going to crash into the back of this truck, and for a brief second straight after the collision they're both going to be joined together, and we have to calculate the velocity of the joined car and truck. So we're going to start off by first of all calculating the momentum of the car and truck separately. So for the car we'll do 1,200 kilograms times 5 meters per second, and that gives us a momentum of 6,000. We do the same thing for the truck, and that gives us a momentum of 40,000. We now need to work out the total momentum, so just add those up and we get 46,000 kilogram meters per second. Because we said that the momentum before an event is equal to the momentum after an event, that means the momentum after the event is also going to be 46,000 kilogram meters per second. We now need to work out the total mass of the joined car and truck. That's quite straightforward. We just add 1,200 kilograms to 20,000 kilograms, and that gives you 21,200 kilograms. We look at our equation again. We plug these numbers into the equation. 46,000 kilogram meters per second equals 21,200 kilograms times v. We rearrange to make velocity the subject, and we should get our final answer as 2.17 meters per second. So let's look at examples involving explosions. So a rifle being fired is one such example, and this question says a bullet which has a mass of 0.01 kilograms is fired from a rifle with a mass of 2 kilograms. The rifle recoils with a velocity of 1 meters per second. What is the velocity of the bullet? So we're going to need our equation P equals m times v. I'm going to work out the momentum of the rifle first. So we have 2 times 1, which is 2 kilogram meters per second. Do the same thing for the bullet. We have 0.01 kilograms times v, and we're trying to work out the velocity of this bullet. We're going to use both of those numbers now in the same equation. So we have 2 equals 0.01 times v. We're going to make v the subject, and we should get a velocity of 200 meters per second. Now notice that I put a minus sign in front of that because the bullet is traveling in the opposite direction of the rifle, so we have to give it a direction. Before the rifle was fired, the momentum was 0, which must mean that the momentum after should also be 0. So let's try and explain this. So we've got the momentum of the rifle moving back is 2 kilogram meters per second. I've given it a positive number because it's moving in the opposite direction to where the bullet is going, and the bullet has a velocity of minus 200 meters per second, so that will give us a momentum of minus 2 kilogram meters per second. If we take the sum of this plus 2 and the minus 2, we should get 0, which tells us that our momentum after is 0, and this obeys the conservation of momentum. So that is the end of the video. Thank you very much for watching. I hope you found it useful. I've left a link in the description box to some practice questions with the answers included for you to have a go at.